Hi, my name is Mark Ashenhust. This is my final project 2 for exploring data in Python and R, DAT 301, on December 4th, 2022. Data set I chose was on COVID-19. The data set link is here. I'll be analyzing everything I did using the HTML file provided, which is the one I'll be submitting along with the Python notebook file. This was all done in Python, Jupyter notebooks. Going in, we have over 1 million pieces of data, over 1 million individuals, with 21 columns of information from anywhere from the sex of the patient to the day they died, if they did die, whether they were intubated, they had pneumonia, how old were they, if they smoked. So lots of information that we could move from and use in our data analysis. Instead of using NA values in this data set, it used the values 97, 99, and 98 to be missing data. That was their own decision. And then a 1 would correspond to a yes, and a 2 corresponds to no. So in the case of being intubated, if it was a 1, that means they were intubated, and a 2 would mean that they were not. First thing I did was imported pandas, NumPy, and matplotlib for data manipulation, for data visualization. And then I loaded in the data and printed out the first 5 values just so I can see that everything was loaded in correctly. So I see I have 21 columns and then the first 5 individual users, individual people that we're looking at all the way down to ICU. Understanding the data set. So here, the part of this section was just so we could see within the data we were given, we understand what we're looking at. So the first thing we have here is we can see we have 1,048,575 individuals in this data set with 21 columns or individual traits. So here they are all listed, and all but date died is an integer value, 64 bits. Date died is in the class of string, which is noted down here. And then the next thing I check for is we can see that there are no null values anywhere found in the data set. This is because we use those 97, 98, and 99 values as our null values. We have 20 integer, 1 object. First analysis that I did were to analyze all of those. So going down those 21 different types, I wanted to see sex. I wanted to see how many were male, how many were female. I wanted to see how many were intubated, how many were not, how many had pneumonia, how many were not, pregnancies, diabetes, all the way down. So we could see here that the female versus male population was split pretty well. Intubated, there are lots that we didn't keep track of, 848,000 out of 1.05 million. So that's we didn't have a lot there. And then, so lots of information, lots of stuff to be reported. So the first graph I did was a little part of this information I got here is I wanted to see it just a visualization so we could see the differences, the discrepancies between 2 forms, whether a lot of people had pneumonia or not. So to show this, we see that with sex, male and female, that they were very similar, very neck and neck. They're very much the same. We'll see that in the histogram here, the representation of women and men. But looking at the next one I did with COPD, we can see that almost no one had COPD. A positive COPD diagnosis was almost nothing. And then there were still a few that were recorded. Over 1 million. We had over 1 million were negative. So the not recorded, this is a lot better than what we were seeing with, like, say, ICU here, where 848,000 were not recorded, where we didn't know that value. The next thing was trying to find correlations. So I wanted to see if there was a correlation between someone having pneumonia to being intubated, right? Does having pneumonia give you a higher chance of being intubated? And looking at this, we can see that no, the answer is no. So this considers that you have pneumonia, that you were intubated. So here this is saying you were intubated, and then did you have pneumonia or did you not have pneumonia? Here it's saying that if you did have pneumonia, there was a very high chance that you were going to be intubated. So that's a very good thing to notice, because then we can check there and see, did they die, right? So we can also see if does having pneumonia give you a higher chance of being intubated? Yes, it does. And does that give you a higher chance of dying? So then we have a three-way correlation. Next thing I wanted to do is compare times of death. So I took out dates and death, and I wanted to see when were most people dying. And also from this, I could see the range of dates if I ordered it, which I did. I ordered in an ascending time. So it began at the latest time, so most in the past, all the way to now, so, which was about January of 2022, going all the way back to January of 2020. So just about 2 years of information. And we can see in 2020 very high. It was very high around April, May of 2020, and all the way to October of 2020. But there were still very high peaks up until the beginning of 2021. From there, so that's a visualization of that. I wanted to look at what it looked like, just what were the deadliest days and what were the least deadly days. The least deadly days don't really matter because there were probably a lot here that were a 1. I only looked at the top 5, but the top 5 most deadly we can see were in June and July of 2020, topping almost 1,000 people dying per day. And those are those spikes we're seeing here in this graph. Furthermore, into our last 2 analyses that I did, I wanted to look at diabetes, seeing if are you more likely to die from COVID-19 if you had diabetes. Turns out that no, being a diabetic didn't have too much of an influence on dying from COVID-19. And then the next one I wanted to do is seeing if you were immunosuppressed, if that gave you a higher chance of dying from COVID-19. It turns out that was actually less of a population in this data set, that there were 22% of diabetic individuals who died from COVID-19, but there were only 18% that died from being immunocompromised or immunosuppressed, which was surprising to me. I would have thought that that would have had a higher population. However, the last one I did dealt with going back to pneumonia, looking at that. And it turns out pneumonia did have a very high, almost 40% correlation with dying from COVID-19. So out of that million people, there's an idea of a 40% chance of that you would end up dying if you had pneumonia and COVID-19 at the same time. And then the last analysis I did was an age analysis, seeing which ages were most likely, most susceptible to death from COVID-19. And it's as you would suspect, it's around the age, the highest age is 65, second is 61, third 66, 60, 63. So the top 5 are all hovering around about the age of 64. 64 would probably be the average there. And in total for the top 30, it's between about 50 to 70 years old is what we're going to be seeing for most of the people that will be dying from COVID-19. So that is my final analysis there. Thank you.